Hey everyone, you're starting a new topic on polynomials today. Remember that I said last term we're going to start something new and you're going to have a printed booklet of all the PowerPoint slides that we're working through. So this is in the cupboard on top of the textbooks. Make sure you've got that booklet in front of you, and then as we're filling in the answers, you fill them in. You might need to pause the video as we go. All right, so polynomials. Now this looks really complex here, but I promise you it's not as tricky as it seems. So a polynomial, which we use px, of degree n is greater than 0, is an expression of the form polynomial x equals p0 plus p1x plus p2x squared plus p3x cubed, and so on. Okay, where the real numbers p0, p1, p2 are called the coefficients. Okay, the degree is the highest power of x occurring, and the leading coefficient is the coefficient of the highest power of x. Now, this seems complex, but I promise you it's not as hard. So here we're going to write down the degree, the leading coefficient, the constant term, and the number of terms in each polynomial. So here we're looking for the degree. So we're looking for the highest power of x, and that tells me the degree. So I can see the highest power of x here is to the power of 4. So that means the degree of this polynomial is 4. Okay. Now I'm looking for the leading coefficient. So I'm looking for the coefficient of the highest power. Now the coefficient means the number in the front. So the leading coefficient is 9. If I was looking for the leading term would be 9x to the power of 4. Okay. Then I'm looking for the constant term. A constant means that it doesn't change and it's a number just on its own. So the constant term is 1. There is no x with it, so it's a constant. That's the constant term. The number of terms, so we've got 1, 2, 3, 4, 5 terms in each. So let's just go through and check we get those answers correct. So we've got a degree of 4 because our highest power of x is to the power of 4. Our leading coefficient, so the coefficient of that highest degree is 9. The constant term is 1, and the number of terms is 5. Okay, let's have a look at B. Here we've got a degree of 2. The highest power of x is 2. The leading coefficient, so the coefficient of that highest power of x is 5. Remember, coefficient means the number out the front of the x. The constant term, so the term that doesn't change, the term that doesn't have an x connected to it, is 13. And the number of terms is 3. We've got 1, 2, 3 terms. Okay, here, let's think the degree. What's the highest degree here? It's going to be to the power of 9. So the degree of this polynomial is 9, which means the leading coefficient, the coefficient of the highest degree, is 17. We have a constant term of negative 44. Okay, remember this isn't just 44, this is negative 44. And we have 3 terms, 1, 2, 3. Okay, so degree of 9, leading coefficient is 17, constant term is negative 44, and the number of terms is 3. All right, let's look at the final one. So the degree here, now we've got no x, which means technically we have x to the power of 0, which means our degree is 0. Okay, our leading coefficient is 24, because it's the biggest one we have. It's also the constant term, and there is only 1 term. All right, so a monic polynomial is one where the leading coefficient is 1. So firstly, we're going to determine if the following expressions are polynomials, and if so, are they monic? So looking here, this expression is a polynomial because we've got x to the power of 5, and then we've got an x. Okay, so yes, this is a polynomial. And is it monic? Let's check. Is the leading term 1? So the highest degree is to the power of 5, and technically this is a 1. So yes, it is also monic. All right, this is not a polynomial because x is on the bottom of the fraction, so not polynomial. Okay, they are only polynomials if we have x to the power of a whole number. Okay, and this is x to the power, but it's on the bottom of a fraction, and it's not a polynomial. Here, this is also not a polynomial because we've got an x squared. So we only want x to the power of something. We don't want it on the bottom of fractions. We don't want them under square roots. We just want x to the power of something. Okay, this is also not a polynomial because we have x to the power of -2. And if you go back to the previous slide, you can see it's where the degree is greater than or equal to 0. And this is less than 0, so it's not a polynomial. Okay, so for this polynomial here, so can you see how this is a polynomial? You've got x squared and you've got x. There's no fractions, there's no square roots. There still can be fractions in the polynomial, but as long as the x is not part of a fraction or a square root. And all the degrees are equal to or bigger than 0. So what this means is we're going to find the value of P2. So see how here we've got the brackets Px, and our terms are in x. So when I want to find the value of P2, what that means is in everywhere that I see an x, I'm going to put a 2 instead. So I'm going to write out the polynomial. Polynomial of x equals 2x squared plus 3x minus 4. And I'm going to sub in a 2, so polynomial of 2. So see how I've subbed this in to be a 2? That means everywhere I see an x, I'm going to put a 2 instead. So it's going to be 2 squared plus 3 times 2 minus 4. Okay, 2 squared is 4, and 2 lots of that is 8, plus 6 minus 4. 8 plus 6 is 14, take away 4 is 10. You could just put that into your calculator though. Okay, we're going to do the same thing now, but for minus 1. So again, I'm just going to write out my polynomial. Where I have an x, instead I'm going to put minus 1. So here it's going to be 2 of minus 1 squared, plus 3 times minus 1, take away 4. So minus 1 squared, remember that's minus 1 times minus 1, which is positive 1. Times that by 2 is 2. 3 times negative 1 is negative 3. Take away 4. So 2 take away 3 is negative 1. Take away another 4 is negative 5. You could just put that into your calculator. Remember to make sure you're putting brackets in your calculator so it knows when it's squaring it to make it positive. Okay, so these are the questions that you're going to work through. So you're doing questions 1 to 5 and then the extension question number 6 if you get up to it.